Alright, with our function app resource up and running, we can now develop the actual logic for this function. What you need for that depends on the language you want to develop in. For us, that's C#, and it also depends on your IDE of choice. I've been using Visual Studio in this course and I will keep on doing so. To develop Azure Functions with Visual Studio, you need to make sure that you have installed the Azure Development Workload. If you're not sure you've got that, open the Visual Studio installer, click Modify and make sure it is checked. As a quick FYI, some of you will probably prefer working with Visual Studio Code, I assume. To enable Azure Function App Development from that, you'll want to install the Azure Functions Core tools. You can find them via the link on screen. This provides you with a set of CLI commands you can use to create, develop, test, run, and debug functions. Anyway, I'm going to switch to Visual Studio. Here's our starter solution. Let me add a new function app project to it. You should see the Azure Functions template. Let's select it and click Next. I'm going to name this one Travel Inspiration API.itineraries. Let's click Next. We're choosing the .NET 8 isolated mode, as that's the one we also selected on the portal when we created the function app. And I am going to choose a trigger here. But what should we use to trigger our function? In our case, we want to use an HTTP trigger, as we want our function to be executed when a request is sent to the endpoint to get the itineraries. We need an HTTP trigger, but as you can see from this list, a lot of other triggers are supported as well, and some of these things you select are not triggers but will result in a different template being executed and thus different sample code being started. In fact, we will use this durable functions orchestrator later on in the course. But what we need now is an HTTP trigger, so I'm going to select that, and I'm going to leave everything else at its default except the authorization level. I'm going to put that to anonymous. Two other options, function and admin, both mean that an API key is required to access the function. A function API key or your master admin API key, respectively. More on that is coming up later on in this section. Let's click Create. Alright, let's inspect the code base here. I'll start with the program class. In this program class, the host is set up via configure functions web application, and the services required by the function are added and configured to the container. This should feel quite familiar if you've ever worked with ASP.NET Core. All that's done in configure services is adding the necessary application inside services and setting that up for a function. If we look at the dependencies, we see that a set of packages related to Microsoft.Azure.Functions.Worker have been added. These are the packages required for building functions in the isolated worker model mode. Next to that, we see that the regular ASP.NET Core framework classes have been added as well, so they are available to us. And as already mentioned, application insights has been set up, and that requires a package as well. One function class named function1 has been added here as well. I'm going to rename that one to getItineraries function. And let me clean this up a bit to file scope namespace. And I'm going to make sure I name the function here getItineraries function as well. That's the actual name of the function. So it's like that we can refer to it. And I kind of like it to match my class name and file name. The run method is where the code that needs to be executed goes. You can see that there's one parameter that's passed through to the run method of type HTTP request, REQ. This is the incoming HTTP request. Through it, you can get a hold of the request body, route values, query string parameters, and so on. All you may need to execute the logic in this method. What is passed in here depends on the type of trigger. We get passed in an HTTP request because we're using an HTTP trigger. Were you to use a queue or a blob trigger, then you would get different data passed in your function. The incoming request is annotated with the HTTP trigger attribute. In this attribute, we can configure the trigger. The authorization level is set to anonymous, as that's what we selected, and a parameter list of methods is passed through as well. These are HTTP methods that trigger this trigger. Get is sufficient for us. We can remove post here. There's another parameter of importance here as well, route. With that, we can pass through the route to the function. If we don't pass through the route will simply be the function name. So something along the lines of API/get itineraries function. That's not very good naming in my opinion. Itineraries for an itineraries resource is better naming, just like in the travelinspiration.api project. All right, let's give this a try. I'm going to set the function app project as starter project. And let's start debugging. What you can see is that the Azure Functions core tools are launched now, which initialize the Azure Functions.net worker process and eventually hosts the function locally. In the output, we see there's one function detected here, which is triggered by a GET request to API/itineraries. I could now control-click this so it would open in a browser, but we actually have an HTTP file here from the previous module, which we can use for sending requests. So, the host was HTTP and port 7173. And down here we have a GET request to API/itineraries. Let's send that. And we get back, welcome to Azure Functions. So there we go. Our function is up and running. Now let's implement this so it actually returns itineraries. We can go about this in various ways. We have a dependency on an Azure SQL database, which we currently work with via Entity Framework Core in the API project. We could go that way, and in fact I will show you how to do that during this demo, but first I want to look into those bindings I mentioned. There's many different bindings for different Azure services. In this case, we want to read data from an Azure SQL database. Reading, that's input. So we need an input binding. And we need an input binding to bind to a SQL database. For that, we need a specific package that includes this. Let me open the NuGet Package Manager. And let's search for Microsoft.Azure.Functions.Worker.Extensions. What you see here is a bunch of packages listed by extension type. There's extensions for working with Service Bus, which includes bindings for working with that. There's extensions for working with storage queues, which includes bindings for working with that. But as you can guess, we need the one that enables working with SQL Azure databases. So let me add .SQL. And here's the SQL extension for .NET Isolated Azure Functions. Let's install it. And there we go. Let me open the function. All right, so what we want to do now is bind a parameter to a SQL statement. And after having executed the SQL statement, the parameter should contain the itineraries that we want to return. We haven't got a class to hold those itineraries yet. So let me add one. I'm going to add a models folder here. And I'm going to add an itinerary DTO to it. I can just copy this one over from the travelinspiration.api project. Let me clean that up a bit. Seeing we are going to connect to a SQL database, I'm also going to need a connection string. I've still got that from the Getting Started course, as it's the same SQL database I want to connect to. So let me add that to the function's local settings here. If you haven't followed the Getting Started course, you can always get the connection string from the overview blade of your SQL Azure database. So there we go, a connection string to my Travel Inspiration database. We are using regular SQL authentication, at least for now. Also important, if you're testing from your local machine, don't forget to enable access to the SQL server from your current IP. For that, open the portal, navigate to your SQL database, for example, click Set Server Firewall here, and add your local current client IP. I'm still good, seems I've been having the same IP for a while, so the rule was already there. Alright, that's it for the moving pieces. Now we can use an input binding. So let me open the function again here. It's the SQL input binding we want. That's defined in Microsoft Azure.functions.worker.extensions.sql. So let's import that namespace. I can input a few things here. First thing I want to input is the command text. This is the query I want to execute. What I want to select are the ID, name, description, and user ID from the itineraries table. Then I can set the command type. This should feel quite familiar if you've used ADO.NET ages ago. System.data.commandtype.text, because we're not fetching a table directly and we're also not executing a stored procedure. We're passing through the query as command text, so the command type should be put to text. And I also need to pass through where the connection string can be found. We named that one Travel Inspiration DB Connection. So that is how we refer to it. So what we wanted was that the results of this query end up in a variable. That variable is an IEnumerable of itinerary DTO. We define that one in the models namespace. Now let's name it itineraries. And there we go. This is how we define a binding. From this moment on, we've got this variable itineraries, which we can work with now inside of this method. Sometimes that simply means returning what we got from the database as a DTO. It may also mean that you first need to transform it, maybe execute some additional logic on it, and so on. For example, if you're updating an entity, a typical thing to do would be to add a SQL input binding to get the entity you're trying to update first, then apply the change inside of the function method, and then use a SQL output binding to save the changes back to your database. What I'm going to do is simply return these itineraries for now. And before I forget, the SQL parameters for the binding. Those are empty for this first demo, but if you don't pass them through as an empty string, the binding won't work. It won't even compile, actually, due to the parameters value being null, and that is not allowed. Let's give this a try. Our function app has launched. There's one function defined in it. Let's send this request. This time I'll do it by simply opening the URL in a browser. And there we go. Here's our itineraries. So this seems to work just fine. And all of that with just a few lines of code. So this looks easy and convenient, right? Well, yes and no. While these bindings are great for simple use cases, I personally feel that you quickly run into limitations. Let me give you an example. Originally, getting the itineraries allowed us to pass through a search for value via the query string. You can still see that in the example requests. Here on line 39, you can see that getting the itineraries support the search for query string. So let's add that as a parameter and use it in the query. You do that with an @ sign followed by the name of the query string parameter key, and that is then coming from the query string's search for key. Then I adjust the query a bit with a where clause. So let's say where either this parameter value is null, or the name is like that parameter value, or the description is if it's filled out. That should do it. Let's give this a try. And let's get the itineraries again. I first want to get them without passing through a value for search for.